Delta is a versatile family of expendable launch systems that has provided space launch capability in the United States since 1960. There have been more than 300 Delta rockets launched, with a 95% success rate. Two Delta launch systems, Delta II and Delta IV, are still in use, though the Delta II will soon be retired. Delta rockets are currently manufactured and launched by the United Launch Alliance. Delta origins. The original Delta rockets used a modified version of the PGM-17 Thor, the first ballistic missile deployed by the United States Air Force, as their first stage. The Thor had been designed in the mid-1950s to reach Moscow from bases in Britain or similar Allied nations, and the first wholly successful Thor launch had occurred in September 1957. Subsequent satellite and space probe flights soon followed, using a Thor first stage with several different upper stages. The fourth upper stage used on the Thor was the Thor Delta, Delta being the fourth letter of the Greek alphabet. Eventually the entire Thor Delta launch vehicle came to be called simply, Delta. The Delta name stems from its position as the fourth, or D version, of the Thor-based rocket combination. The vehicle has been known both as Thor Delta and simply Delta. NASA intended Delta as an interim general-purpose vehicle to be used for communication, meteorological, and scientific satellites and lunar probes during 60 and 61. The plan was to replace Delta with other rocket designs when they came online. The Delta design emphasized reliability rather than performance by replacing components which had caused problems on earlier Thor flights. NASA let the original Delta contract to the Douglas Aircraft Company in April 1959 for 12 vehicles of this design. Stage 1, modified Thor IRBM with a block IMB-3 engine producing 152,000 pound-forces thrust. Stage 2, modified Able. Pressure-fed UDMH nitric acid-powered Aerojet AJ-10-118 engine producing 7,700 pound-forces. This reliable engine cost $4 million to build and is still flying in modified form today. Gasjet attitude control system. Stage 3, Altair. A spin stabilized at 100 rpms by two solid rocket motors before separation. One ABLX-248 solid rocket motor provided 2,800 pound-forces of thrust for 28 seconds. The stage weighed 500 pounds and was largely constructed of woven fiberglass. These vehicles would be able to place 650 pounds into a 150 to 230 miles LEO or 100 pounds into GTO. 11 of the 12 initial Delta flights were successful. The total project development and launch cost came to $43 million, $3 million over budget. An order for 14 more vehicles was let before 1962. Thor Delta flights Delta Evolution Delta A MB-3 Block 2 engine, 170,000 pound-forces versus 152,000 pound-forces, 13. EPE-2, 14. EPE-3 Delta B upgraded AJ-10-118D upper stage Euro 3-foot tank stretch, higher energy oxidizer, solid-state guidance system. Delta program goes from interim to operational status. 200 pounds to GTO, 15. December 13, 1962. Relay 1, second NASA communications satellite, NASA's first active one, 16. February 13, 1963. Pad 17B. Syncom 1. Thecol Star 13B solid rocket as apogee kick motor, July 20, 26, 1963. Syncom 2. Geosynchronous orbit, but inclined 33 a degree due to the limited performance of the Delta. Delta C third stage Altair replaced with Altair II its engine having been developed as the ABLX-258 for the Scout vehicle. 3 and longer, 10% heavier, but 65% more total thrust, sample mission, OS04. Delta D also known as Thrust Augmented Delta, a Delta C with the Thrust Augmented Thor Core Plus 3 Caster 1 boosters, 25. August 19, 1964. Syncom 3, the first geostationary communications satellite, 30. April 6, 1965. Intelsat I equals delta E equals, also known as thrust augmented improved delta, 1965, 100 pounds more to GTO than delta D, Castor 2 versus Castor 1 boosters. Same thrust, longer duration, MB3 Block 3 core engine, 2,000 pound forces more thrust, AJ10-118E second stage widened from 2.75 feet to 4.58 feet diameter. Double burn time, additional helium tanks allow for almost unlimited restarts. 2 available third stages, Altair-2 or FW4D. The latter caused the Delta to be known as a Delta E1, new payload fairing from Agena, first Delta E November 6, 1965. Launched GEOS-1 equals Delta F equals, this launch vehicle was not built. Equals Delta G equals, two-stage vehicle. Only used for 2 launches, Biosatellite 1 on December 14, 1966 and Biosatellite 2 on September 7, 1967. Equals Delta J equals, used larger Thiekl Star 37D motor as third stage. Only 1 launch of this configuration on July 4, 1968. Equals Delta K equals, this launch vehicle was not built. Equals Delta L equals, introduced extended long tank first stage 8 feet diameter throughout, used the United Technologies FW4D motor for third stage. Equals Delta M equals, 3-stage configuration. Long tank Thor augmented with 3 Castor 2 boosters. Delta E second stage, Star 37D for third stage. There were 12 successful Delta M launches from 1968 until 1971. Equals Delta N equals, 2-stage configuration, long tank Thor augmented with 3 Castor 2 boosters. Delta E second stage, there were 6 successful Delta N launches from 1968 until 1972. Equals Super 6 equals, Delta M or Delta N with 3 additional Castor 2 boosters. These were designated as either M6 or N6. 1 launch of the M6 configuration, Explorer 43 on March 13, 1971. 3 launches of the N6 configuration, 1 failure. £1,000 to GTO. Launch reliability, from 1969 through 1978, Thor Delta was NASA's most used launcher, with 84 launch attempts. NASA used it to launch its own satellites, and also to launch satellites for other government agencies and foreign governments on a cost-reimbursable basis. 63 of the satellites NASA attempted to launch were provided by other parties. Out of the 84 attempts there were 7 failures or partial failures. Delta numbering system, in 1972, McDonnell Douglas introduced a 4-digit numbering system to replace the letter naming system. The new system could better accommodate the various changes and improvements to Delta rockets. It specified the tank and main engine type, number of solid rocket boosters, second stage, and third stage. This numbering system was to have been phased out in favor of a new system that was introduced in 2005. In practice, this system has never been used. Equals Delta 904 equals. The long tank Thor, a stretched version of the Thor missile, first use of 9 strap-on boosters for Landsat-1 launch on July 23, 1972. First use of new uprated Delta F second stage using Aerojet AJ10-118F engine. This Thor Delta model was designated the 904. Equals Delta 1000 series equals. Nicknamed Straight 8. Extended long tank with 8-foot diameter payload fairing. 9 Castor 2 strap-on solid boosters. The first successful 1000 series Thor Delta launched Explorer 47 on September 22, 1972. Introduction of McDonnell Douglas Delta P second stage using TRW Trail 201 engine. Equals Delta 2000 series equals. Features new rocket dinner S-27 main engine on extended long tank. Same constant 8-foot diameter. Delta 2910 boosters were used to launch both Landsat 2 in 1975 and Landsat 3 in 1978. First time 3 satellites launched simultaneously on Delta 2310 Modella Euro November 15, 1974. A Delta 2914 was used April 7, 1978 to launch the Japanese BSE broadcasting satellite, also known as Yuri-1. Delta 3000 series introduced upgraded caster 4 solid motors. Same first stage as 1000 and 2000 series. Introduced PAM Star 48B solid-fueled kick motor. Later used as Delta 2 third stage. The Delta 3914 model was approved for launching U.S. government payloads in May 1976. The Delta 3914 model was launched 13 times between 1975 to 1987. Last Delta series to use the MCD Delta P second stage with TRW Trail 201 engine. Delta 4000 series used old MB3 main engine on extended long tank with caster 4 motors, first use of a Delta K second stage. Only launched 2 missions. Delta 5000 series featured upgraded caster IVA motors on extended long tank first stage with RS-27 main engine. Only launched 1 mission. Delta 2 series The Delta 2 series consists of the retired Delta 6000, the active Delta 7000, and 2 variants of the latter. It was developed by Boeing at Chatsworth and Canoga Park, California, and its engines were tested at Boeing's Santa Susana Field Laboratory located northwest of Los Angeles in the SME Hills. Delta 6000 series, when in 1986 the Challenger accident demonstrated that Delta launches would continue, the Delta II was developed. Introduced extra extended long tank first stage. 12 additional feet provide more propellant. Introduced caster IVA boosters. 6 ignite at takeoff, 3 ignite in flight. Delta 7000 series introduces RS-27A main engine, modified for efficiency at high altitude, at some cost to low altitude performance. Introduces GEM-40 solid boosters from Hercules. Besides being longer, their lighter casings allow higher payload capability. Delta II Med Light, a 7000 series with no third stage and fewer strap-ons. Usually used for small NASA missions. Delta II Heavy A Delta II 792X with the enlarged GEM-46 boosters from Delta III. Delta III A McDonnell Douglas Boeing developed program to keep pace with growing satellite masses. The 2 upper stages, with low-performance fuels, were replaced with a single cryogenic stage, improving performance and reducing recurring costs and pad labor. Engine was a single Pratt & Whitney RL-10, from the Centaur upper stage. The hydrogen fuel tank, 4 meters in diameter in orange insulation, is exposed. The narrower oxygen tank and engine are covered until stage ignition. Fuel tank contracted to Mitsubishi, and produced using technologies from Japanese HII launcher. To keep the stack short and resistant to crosswinds, the first stage kerosene tank was widened and shortened, matching the upper stage and fairing diameters. 9 enlarged GEM-46 solid boosters attached. 3 have thrust vectoring nozzles. Of the 3 Delta III flights, the first 2 were failures and the third carried only a dummy payload. Delta IV As part of the Air Force's EELV program, McDonnell Douglas Boeing proposed Delta IV. As the program implies, many components and technologies were borrowed from existing launchers. Both Boeing and Lockheed Martin were contracted to produce their EELV designs. Delta IVs are produced in a new facility in Decatur, Alabama. First stage changed to liquid hydrogen fuel. Tank technologies derived from Delta III upper stage, but widened to 5 meters. Kerosene engine replaced with rocket dinner S-68, the first new, large liquid-fueled rocket engine designed in the U.S. since the Space Shuttle main engine in the 70s. Designed for low cost. Has lower chamber pressure and efficiency than the SSME, and a much simpler nozzle. Thrust chamber and upper nozzle is a channel wall design, pioneered by Soviet engines. Lower nozzle is ablatively cooled. Second stage and fairing taken from the Delta III and smaller models. widened to 5 meters in medium plus and heavy models. Medium plus models have 2 or 4 GM 60-inch diameter solid boosters. Revised plumbing and electric circuits eliminate need for a launch tower. The first stage is referred to as a common booster core. A Delta IV Heavy attaches 2 extra CBCs as boosters. Delta IV Heavy. The Delta IV Heavy uses 2 additional CBCs as boosters. These are strap-on boosters which are separated earlier in the flight than the center CBC. The initial demonstration flight on December 21, 2004 was a partial failure, due to the premature cutoff of CBCs. The demo sat reached incorrect orbit and the 3 CS satellites entered orbit at a height of only 105 kilometers, which led to a rapid decay. The cause of the problem was a faulty first-stage LOX depletion sensor signal that resulted when LOX cavitation occurred in the LOX feed line. The LOX feedline sensor design was modified and the problem did not recur on subsequent Delta IV Heavy missions. Features a stretched 5-meter composite payload fairing. An aluminum trisector fairing derived from the Titan IV fairing is also available. This was first used on the DSP-23 flight. First successful launch from Space Launch Complex 37 at the Cape Canaveral Air Force Station on November 11, 2007. First successful launch from Vandenberg Air Force Base's Space Launch Complex 6 on January 20, 2011. On August 28, 2013 a Delta IV Heavy was launched from Vandenberg Air Force Base's Space Launch Complex of the National Reconnaissance Office's the top-secret NROL-65 payload successfully into orbit. http://www.youtube.com/ Watch ?v GL1DEBZ6 See also, Comparison of orbital launchers families, Comparison of orbital launch systems, List of Thor and Delta launches, Beloved, Contribution to Space Debris, Echo 1, Project Echo. References. Forsyth, Kevin S. Delta, The Ultimate Thor. In Roger Launius and Dennis Jenkins, To Reach the High Frontier. A History of U.S. Launch Vehicles. Lexington, University Press of Kentucky. ISBN 0-8131-2245-7. External links, History of the Delta Launch Vehicle, Delta Launch Record, The Satellite Encyclopedia, Thor Delta.